Welcome to the 10.5 podcast. Centrifugal force in a rotating reference frame. The centrifugal force as an effect of rotation is not part of an interaction, and therefore it cannot be called a true force. So let's go back to that ladybug in the can, and let's pretend that we are the ladybug. So this is from the frame of reference of the ladybug inside the can. What the ladybug is going to feel is that it's being pulled to the bottom of the can by a force that comes from the center, directed away from the center of circular motion, meaning it's a force pulling it from outside that circle. So we can see that there is no centrifugal force acting on the ladybug inside the whirling can. There's nothing pulling, pushing. There's no magnets. There's no gravity pulling the ladybug out. It's all due to the centripetal force that's acting on the can, which is producing the circular motion. So if you look from the reference can of the rotating difference, it's different. If you use the whirling can as a frame of reference, you can see that there's both a centripetal force supplied by the can, which means a force pushing in, and a centrifugal force supplied by the ladybug pushing out. So the centrifugal force isn't acting on the ladybug; it's acting from the ladybug. So the centrifugal force appears as a force on its own right, and it feels just like it's gravity. However, there's no interaction. There's always an interaction between two pairs of forces, and in this gravity, we know that we pull on the earth pulls on us. There's an interaction. But in the rotating frame of reference, there is no interaction for the ladybug feeling the centrifugal force. So we call the centrifugal force a fictitious force. And somebody in a rotating system might say, wow, I feel the force that's pushing me down. Just as it feels like gravity. But it actually doesn't exist. So here's a great example of what we feel like a centrifugal force, and it's a gravitron. We all are familiar with that. This barrel shaped right here rotates around, and you sit on these cushions on the inside of the ride, and you're basically pressed up against the wall. And really what that is that's your inertia acting on the outside of the wall of the gravitron. So a heavy iron ball is attached to a spring in a rotating platform as shown in the sketch. Two observers, one in the rotating frame, which would be this boy right here, and one on the ground at rest, observe its motion. Which observer sees the ball being pulled outward, stretching the spring? Which observer sees the spring pulling the ball into a circular motion? Well, the answer is that the one who's in the rest frame sees that the force is stretching the spring, and the one that's outside of it will see that the ball is being moved in circular motion. So let's talk about simulated gravity. You could put ladybugs inside a bicycle wheel and then rotate that bicycle wheel, and it would feel as if the ladybugs are being pressed against the outside of the wheel away from the center of rotation. So they're up, quote unquote up, is really toward the center of the wheel, and their down is actually outward away from the center of the wheel. This can be done with devices in a lab. They make a quote-unquote centrifugal force by simulating gravity using these giant centrifuges, and this is done with astronauts. Now, if you look here, you can see a man inside a rotating, looks like a tire, but really it's probably supposed to represent a space station. And if you look at the man and the floor is pressing against the man from the bottom, and the man is pushing on the floor. So the only force directed on the man is actually a force towards the center of the circle. Whereas if you're inside the the rotating system and you're the man, it would actually feel like you're being pulled away from the center of rotation. And that's the fictitious centrifugal force effect. So now you can actually use this to create a gigantic space station. You've probably seen these before, maybe in a magazine. And they have thought about making space stations using these gigantic wheel-like structures. And there's some limits on what they could do. It'd have to move no faster than 2 to 3 RPM because people can't do it much higher than that. So basically it would probably have to spin around 1 RPM. Means 1 full rotation in a minute, which means it would go around once every 60 seconds. And in order to make the gravity feel real like it does on Earth, because of this very slow rotation, the diameter of the space station would have to be 2 kilometers from here to there. It'd have to be 2 kilometers. That's pretty enormous. So there was a movie called 2001: A Space Odyssey, which was released in the 70s, and parts of it took place on a space station that looked like this, and basically it was 2 wheels together, so they were getting double the space. And this is what one of these rings around here look like. It actually looks like a curved hallway, and that was the idea behind the space station, was that it was simulating gravity in this gigantic rotating wheel structure. And then there was also a spacecraft involved with that, and they simulated gravity in a circular part of it. And you can see this man, he sort of looks like he's running downhill, but he's actually running around and around in a circle, and it was a really clever trick the way they filmed that part of the movie. So why is centrifugal force not considered a true force? Centrifugal force is an effective rotation. It is not part of an interaction, and therefore it cannot be a true force.